So the last thing we discussed was covalent bonds. Covalent bonds are caused by the sharing of electrons, but those of you who have siblings know that sharing isn't always fair. Sharing isn't always equal. The same can happen in the molecular world. What we'll find is that sometimes one atom is going to be able to attract electrons to a greater degree than another atom. When this happens, it's going to create a polarity or a partial charge at one end of a molecule. And polarity is going to affect how molecules are able to interact with one another. So when electrons of a covalent bond are shared unequally, the bond itself is called polar, and the resulting molecules are going to be what's known as polar molecules. And water is a great example of this. We're going to spend a little bit of time looking at water as a polar molecule. So I'm going to skip those hydrogen bonds for just a moment and move ahead to this slide, and then we'll back up. So here's an example of a polar molecule. Here we have oxygen. Oxygen has how many electrons in its valence shell? 1, 2, 3, 4, 5, 6. How many electrons does oxygen want in its valence shell? 8. Yes, we always want to have 8. If we have more than one energy shell, we want to have 8 electrons in that outermost shell in order to be completely non-reactive. So oxygen needs 2 more electrons in order to be satisfied. How many electrons does hydrogen have in its valence shell? Only 1. How many electrons does hydrogen need in order to be completely satisfied? 2. Hydrogen is going to need 2 electrons. So hydrogen is going to go over to oxygen and say, hey, I will share my 1 electron with you if you will share 1 of your electrons with me. That way I can have 2, you can have 7, you're closer to your 8, and I'm completely happy. Oxygen says, okay, that sounds fair, let's do it. Oxygen will then go to another hydrogen and say, hey, look at you. You have only 1 electron, you need 1. I have 7 electrons, I need 1. Why don't we share a pair of electrons together, and then you can have 2, I can have 8, I'll be happy, you'll be happy, everybody's happy. Hydrogen says, all right, cool, sounds fair to me, I'll do it. Here's the thing. Oxygen is a little bit of an electron hog, and what's going to happen is that this pair of electrons that's being shared back and forth between hydrogen and oxygen, yeah, it's not going to be shared equally. This pair of electrons is going to spend more time orbiting oxygen than it is hydrogen. He is going to orbit hydrogen. Hydrogen is going to have a completely satisfied shell, but those electrons are going to spend more time hanging out with oxygen than they are with hydrogen. Same with the pair that's being shared over here. It's going to spend more time orbiting oxygen than hanging out with hydrogen. What happens is because all of the electrons are spending more time with oxygen, we're going to see a partial negative charge. Now the molecule itself, completely balanced. We have just as many positive charges as we have negative charges, but all the negative charges that are hanging out over here, which is leaving a positive void down here and down here. This is what is called a polar covalent bond. We are creating a north pole and a south pole, a negative pole, a positive pole. We are creating an unequal balance of charges. So this is what's known as a polar molecule. When we have a bunch of polar molecules together, a whole bunch of water molecules together, we can start to form what are known as hydrogen bonds. Hydrogen bonds form when a slightly positive hydrogen atoms of one water molecule are attracted to the slightly negative oxygen atoms in another water molecule. And these hydrogen bonds are going to be very, very weak. Now, I know that's a lot of words, so just write them down. Take a moment, write them down before you move on. But then that way you'll have your notes when you're looking at these next couple of slides. So here's an example of what those hydrogen bonds look like. Here we have one water molecule, our oxygen here with its slight negative charge, our hydrogen atoms down here with their slight positive charge. This oxygen atom with its slight negative charge is going to be attracted to the slight positive charge over here of this hydrogen ion. So they're going to form a very, very weak hydrogen bond. Now this is not as strong as an ionic bond. An ionic bond is formed between a fully negative ion and a fully positive ion. It's a very strong bond. These aren't fully negative or positive. There's a slight negative charge here and a slight positive charge here. So it's like an attraction between 2 very weak magnets. But here's the thing. When you have a whole bunch of very, very weak magnets, they become very strong very quickly. You can kind of think of it as a zipper. If you've ever pulled on a zipper or a coat that's been zipped up, it's very difficult to break a zipper apart. However, you can go through, you can take your little metal piece and you can unzip, you can break those bonds one at a time. Individually, hydrogen bonds are crazy weak. Together, they are very strong. And this is so important because there are actually a lot of molecules that are held together by hydrogen bonds. Not just a glass of water, but proteins are held in place by hydrogen bonds. DNA is held in place by hydrogen bonds. We are going to come back to these hydrogen bonds over and over again. So make sure you have a really strong understanding. And if you don't, let me know. Come and talk to me during one of our meetings. And I would love to take that time to catch up with you on hydrogen bonds. The last thing I want to mention for this section is going to be this table 2.2 to review chemical bonds. Go over the different types, covalent, ionic, and hydrogen. Know what the basis of attraction is. For covalent bonds, it's going to be a sharing of electrons. Sometimes it's an equal sharing of electrons. Sometimes we share fairly. Sometimes we do not. So sometimes we have polar covalent bonds and sometimes we have non-polar covalent bonds. And we'll break that down a little bit further along. But these are going to be very strong bonds. A great example of this would be methane. Ionic bonds are going to be caused by the transfer of electrons. Someone's going to give up an electron, someone's going to pick up an electron. And so we're going to have a positive charged ion, a negative charged ion, and an attraction between those two. Finally, hydrogen bonds are going to be caused by an attraction between partial charges. One atom is partially negative, the other atom is partially positive. And so we're going to have a very weak attraction between those two partial charges. All right, and that's it for this section. I'll see you in a bit for more on water.